Okay, we're rolling.
Okay.
Yeah, you're looking good. All right, let's so we covered addition of fractions, and subtraction works the same way, but you'd have to have a common denominator.
Yes.
Okay, so let's just talk very, very quickly about multiplication and division.
Yes, sir.
And that's easy.
Okay.
Okay, so we were using 2/3 times 3/4. Now, do you remember what to do with multiplication?
Yes.
What do you do?
Because they both are not the same, we have to find the least common denominator.
Yeah, most people make that mistake. You do not have to find a common denominator when you're multiplying.
Okay,
or dividing.
when you multiply. Okay.
You multiply or divide, you do not have
multiply. Cross multiply.
And when you say cross multiply, what do you mean by cross multiplying?
Okay. How many times this 2 can go into this 4, which is...
No. We don't do that. All we do is multiply. When we say cross, we multiply across. Straight across, but not diagonally.
Okay.
So that would simply be 6 over 12.
Yeah.
Now we could say, well, 3 goes to the 3 one time, and 3 goes to the 3 one time over there. You can do that.
Okay.
Okay. But you could do it either way. The reason why this works is because 2 over 3 times 3/4 equals 2 times 3 over 3 times 4. Same thing.
Okay.
That's absolutely the same thing. And then we have a common factor. We can cross them out. Equals 2/4. Or we can say 6/12. Okay, 6 goes into 6. Oh, 2/4. It gives us 2/4, but that reduces to 1/2.
Yes.
You see that? And same thing. Same thing here. We come up with 6 over 12. 6 goes into 6 one time. 6 goes into 12 two times.
Okay.
1/2. That's how you multiply fractions.
Okay.
Okay. Got to remember that, because you look like you were a little unsure whether you multiplied diagonally or straight across.
Okay.
So you have to remember that.
Okay.
Okay. And same thing when we divide. 2/3 divided by 3/4. Now, in this case, what we do is we rewrite the problem and we say...
So division would be multiplication.
Multiplication, and we do one other thing to it. You know what else we do?
You flip the number?
Yeah, we got to make sure you know which you flip the second one.
The second one. So
all right.
3/4.
Let's see. A lot of people are unsure of that. Okay, and then we multiply. 8
over 9.
And you can't reduce that in any way.
Okay.
All right. So those are the rules for multiplication of fractions.
Yes.
Okay. You also need to know. You know what a prime number is, I guess.
Prime numbers are, I think that's what, 2, 3, 5, and 7.
So, but do you know why they're prime? Because they have only them and themselves as multiples.
Okay.
All right. So look, I can write 1, and the only way I can write that in terms of factors, if I make sure that my factors are whole numbers, is 1 times 1. That's the only.
Okay.
Or I can do 1 times 1 times 1 times 1 times 1. You know.
Okay.
That's all I can do with that. If I have 2, the only way I can. Okay. Any number has itself and 1 as a factor.
Okay.
All numbers have that. 3, 4, 5, 6, 7. Okay. So I can say 3 times 1, 4 times 1, 5 times 1, 6 times 1, 7 times 1. So we call that a trivial factorization.
Okay.
Trivial means it's unimportant to us mathematically.
Okay.
Well, I mean, it might be important sometimes, but in terms of factoring, that's not anything we have to worry much about. Okay. The only way we can factor 3 is 3 times 1. Okay. But when it comes to 4, we can say 4 equals 4 times 1, or it equals 2 times 2.
Okay. I see what
So
you're
there's
doing.
two sets of factors here.
Okay.
When we come to 5, there's not two sets of factors.
Okay.
6, do you see another set of factors for 6?
Yes.
What are they?
3 times 2.
All right, 3 times 2 or 2 times 3? 2 times 3, okay?
Mm-hmm.
When it comes to 7, do you see another set of factors for 7?
No.
All right, this is enough right now. The numbers that have only one set of factors, which would be the trivial factorization,
Okay.
is called a prime number.
Okay.
Numbers that have more than one set of factors are called composite numbers.
Okay.
And it'll be very important for us to know the difference,
Okay.
okay? Because even in your test, you had a factor tree, I saw, and they wanted you to factor something into the product of prime numbers.
Okay.
But if you don't know what a prime number is, you'll never, you'd be a little bit lost. When you're constructing this tree, as you put branches on this tree, or leaves, or whatever you want to call them, you look at the number and you say, well, can that be factored further? Well, either can or can't, but you should have some knowledge of when you've ended that process. You ended that process when you come up with a number that can't be factored further. Other than just the trivial factorization. Okay? That's a prime number. Okay. So that's probably enough review here. So now let's take a look. So now let's take a look at the problems in your book. And the first one was
this one. I'm gonna would be
okay.
From on this side.
On this, you want to jump to this side?
No, but it's the questions. I think it might be here, but this right here is what's worse for me. All this I understand.
You think you understand?
Yeah, if I sit there and take my time.
Well, I'm not confident that you have high ability to solve equations yet.
Okay, well we can still work on equations.
Okay, but let's just to make you feel a little bit better. Let's jump further across here right now. It's all good. I wouldn't be doing this.
That's all like.
If I wasn't happy with this, I wouldn't suggest we do it. I'm happy looking at this right now. So show me which one is bugging you right here.
The whole process.
The whole process.
You know, see, this is where I get confused. I wrote it down. She asked to write it down. She says,
let me look more closely at this problem.
Rectangle, base,
this is a rectangle problem.
Triangle, you have 1/2 base times height. Parallelogram, you have base times height. A tripod, which could be a lean-to shed. She says 1/2 equals base base 1 plus base 2. Then you got plus height. That's what I don't understand.
Okay, let's start with the simplest case first. Simplest case would be a square. You know what a square is?
Yes.
All the sides are the same.
Yes.
We just call the side S.
Okay.
All right. Now the two things that we would want to know about these plane geometric shapes. By plane, I mean they're just, you lay them on a table, but they don't have any height to them. Okay, like a square. If it had height to it, it would be a cube. It would be something that looked like that. That's a cube.
Okay.
You know what I mean?
Yeah.
That's a cube. It's solid. Just a square by itself is not solid. This piece of paper, for all intents and purposes, is not solid.
Okay.
It just has dimensions this way. We don't worry about the little thin. Okay. So when you have a plane figure, some of these regular geometric figures, there are two questions they often ask about them. They ask what is the perimeter and what is the area.
From what I know, the area is everything
inside.
I thought inside and outside. That's the whole thing. That's the whole area.
It can't be outside because outside is the whole universe. Okay? Everything. What's outside this piece of paper that I have on my desk? Well, there's Washington, D.C.'s outside of there. California, Los Angeles, the moon and the stars, and Lord knows what else. There's everything outside of this piece of paper. But the only thing meaningful we can ask about this piece of paper, I think, is if I wanted to build a fence around it, how long would the fence be? Or if I wanted to cover this with a rug, how much rug would I buy? You see what I'm saying?
Yes, sir.
You think of it in terms of fences or rugs.
Okay.
Okay? If you had a garden outside, you might want to put a fence around your garden.
Okay.
All right? So you'd have to go to the store, Home Depot or whatever, and you'd have to buy a fence. Now, you don't want to spend $1 million on fence. You just want to buy enough fence for your garden. So you would measure your garden, and you would find out how far it is around your garden. We call that the perimeter.
Okay.
If instead of a garden, this is a kitchen, and we're not going to put fences around our kitchens, but we might want to put floor down in our kitchen. We want to know how much to buy. That's called area.
So area is everything within the circle?
Yes. When you put a rug in your house, you buy a certain amount of rug.
Okay.
Because you're paying by the square foot for rug.
For the area of which you
and you don't want to come up short. You don't want to have the rug go 3/4 of the way across your floor, and then it's just some nasty boards underneath. You want something that's going to cover the whole thing.
Correct.
But you don't want to have it going into your neighbor's yard. You want just something inside your room.
Okay.
And that's the area.
Okay.
Okay?
Okay.
So, two things. We're going to be talking about area and perimeter. Now, for a square, the perimeter, if the side is S, what would be the formula for the perimeter? That's S, that's S, that's S, that's S. They're all
the outside, some kind of everything on the outside.
Yeah. So what would the formula?
Is that 5?
No, that's an S. These are all S's. Side, 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 side.
So my perimeter would be 4 sides.
4S.
4S.
That's your perimeter?
Yes.
Okay. What about area? What would the area be?
Well, you don't say nothing within the circle because you said within the circle.
With inside. What is this area inside here?
It don't say.
And what I'm asking you to say. If I tell you this outside is S, I can construct a formula for the area. You constructed a formula for the perimeter right here because you thought about it. You thought, well, it's just got to be 4S. Well, I'm asking you to think now and tell me what the formula for the area would be. You can't do any of these problems here without this knowledge. So
I wouldn't know how unless there was like something in the middle. I wouldn't know where to go from there.
Well, let me tell you, when you have a square, you simply multiply your side by your side, and that gives you the area.
Okay. And see, my teacher did say that, but I didn't remember that.
Well, that's why we're reviewing it today.
Yes. Yes.
Okay. So it would simply be S times S.
5 times 5 is...
No, that's not 5. That's not 5. That is an S.
Okay. S times S.
I could have made these things X's.
Okay, no, because I thought that was a 5. That's
no, that's not a 5. If they were X's, I'd say the area is X times X.
Okay.
And a short way to write that is X squared.
Okay.
We call that number an exponent.
Okay.
The superscript we call an exponent. X, that indicates that's X times X. Okay? That's X squared. We would say that's X squared. Have you ever seen these before?
Yes.
Something like that?
Mm-hmm.
Okay. Well, that's going to be very important because we're going to have if I have X times X times X, that's X cubed.
Okay.
If I have 5 X's as factors, that would be X to the 5th power.
Okay.
Very important to know that.
Yes. I'm looking in the camera because I don't want to sound rude or anything, but my ride will be here in approximately... You have on your clock what time, sir? Richard.
You call me Mr. G if you want to call me.
Okay, Mr. G. Mr. G.
Okay. I have 4:35.
Okay, because my ride will be here.
We can break any time.
I think, I think I would like to break right now.
You sure you're just getting going?
I'm going to be honest. Why I want to break is because, well, I only bought for 1 hour, and I didn't think I was going to need more than 1 hour. So.
Well, you're not paying for anything more. I'm just saying, I'll spend more time with you.
Oh, okay. No, see, I didn't know, sir. I don't know how it works, so.
Well, I'm only gonna charge you for 1 hour, but if we have to, believe me, I give people their money's worth. So if we go over, you don't have to worry that you're on the clock or anything for paying more.
Yes, sir.
No, flat rate. Okay. So, all right. If we have a rectangle, we often call this length and width.
And width. Okay.
All right. So what would be the formula for the perimeter of a rectangle? The perimeter. You're building a fence. This is your yard outside.
So a rectangle?
Yes.
Rectangle is what's like this, right?
No, what I just drew. Just look what I just drew here.
You have 4 sides.
I have 4 sides. That is there. It's not a triangle. It's a rectangle. We call these rectangles.
Okay. And you ask, state the question again if you don't mind me asking.
Length, width. Length, width, length, width. This is equal to that, that's equal to that, and these are right angles there.
That's 90 degrees when I see
It's
that.
just like this tabletop here.
Okay.
This is a rectangle here. So if I say that's W, and that's L,
okay.
what would be the formula for a little fence that we're going to put around this? In terms of L and W.
W and L.
Now, when you say and, what do you mean by and? Do you mean plus? Do you mean times? Do you mean
times? Well, because you didn't say area, you said perimeter.
Perimeter is not area. Perimeter
is times. Okay.
Perimeter is just a linear measurement. It's just like how many feet. How many feet around this whole thing?
Well, it has to add.
It does. So we have an L plus
W plus L plus W.
All right. L plus W plus L plus W. But I could certainly rewrite that as 2L plus 2W, couldn't I?
Okay.
Would you agree that's the same thing?
You say 2L.
Because we have an L plus L.
Okay, I see.
And 2W because we have a W plus W. Okay?
Okay, so with the L wouldn't be squared, it'd just be L.
No, not yet. No, we're just putting a fence around this whole thing.
Okay.
Now, let's say we want to cover this top with formica or something.
Okay.
We're then talking about area.
Okay.
Okay? And for this rectangle, I want a formula for the area.
Okay.
In terms of L and W. What would I do?
You want a formula for the area. Okay. You want to know, I guess, the area within here. But see,
now think about the square. We finally found the area by multiplying the side times the side.
Okay, so I will multiply W times L times W times
No.
L.
We didn't do. We only multiplied the side by the side. We didn't need to worry about that side and that side. Once we take care of one side, we've taken care of the other.
Okay, so that'll mean just W times W.
W times L, you mean? W times L.
Okay, so it wouldn't go side to side. It would go.
No. Yes.
Okay.
Very important to know that.
Okay.
Well, we used to say length times W.
Okay.
Okay. Now, we'll talk about very quickly about the triangle and the circle.
Triangle and circle.
Okay? Because you need to know about those 4 things. You need to know about the square, the rectangle, the triangle, and the circle.
Okay.
I'm not worried too much about
No, we don't do the circle in our class.
All right, then we won't worry about the circle.
No, for real, we didn't do the circle.
All right, well, they'll probably introduce it later then. We'll just talk about the triangle today.
Okay.
All right. Now, there's special triangles, like a right triangle. Okay.
Okay.
And there's special triangles, like an equilateral triangle, where all the sides are the same.
Okay.
And they have, I guess, when just 2 sides are the same, I think they call that an isosceles triangle, I think. But if we just draw a general triangle, that almost looks like a right triangle, but I'm trying to make something that doesn't. No, that's not a right angle. None of them are right angles. If we just draw a general, I want to draw it like this, actually. Now, that's not supposed to be a right angle. Okay, it's hard to draw one without a right angle. But
something like, what is it?
that's just it's just a triangle with no special angles here and no special sides. Just your general triangle.
Okay.
Okay. Certainly the perimeter would be X, Y, and Z. We don't know what they are, but the perimeter would just be X plus Y plus Z. Okay. If we wanted to build a fence around it, that's how we build the fence.
Okay.
X plus Y plus Z would give us a fence to go around this. Let's say let's say your garden plot outside your house was a triangular shape. You could put a fence around it by doing this way.
Okay.
If you want the area, what we do is we drop a perpendicular down there. So that is a right angle now.
Okay.
Okay? And we're going to call this the height.
Okay.
And we're going to call this the base.
Okay.
So they probably talked about bases and heights in your class.
Yes.
Okay? And the area is just 1/2 the base
1/2
times the height. Okay?
1/2 the base
times the height.
times
1/2 the base times the height.
Okay.
1/2 times B times H.
And that's for a
for any triangle.
For any triangle.
For any triangle.
Okay, for any triangle. So 1/2 base times height. Okay, I have to remember that.
Okay.
Okay.
So now let's look at the problems that you have here, if we can get to one of them today.
Okay.
Next time we won't be spending this much time on review, but I think what we're talking about now is important. It is important for your class.
Okay.
Because you need to have a good foundation here in these things. All right. Well, they're talking about cubic feet already. Now, do you know what a cubic foot is?
She told to how she explained it. She said she explained it, but then she didn't explain it. She was told us really not to worry about it. It's just like when we're doing what have you, we still always have to, whatever we start our problem with, we have to end our problem with. So if it say cubic feet, say inches, anything of that nature, it always has to.
Well, a cube. Let me just show you. I'm going to draw a cube.
Cubes look like a box.
A box, but it has sides. It's a three-dimensional object, like is it like this? Like a dice. You know what a dice is? You know what a set of dice is?
Yes.
Those are cubes.
Is it like this? What they was trying to show you, like this?
No, that's just there. That's just a plane figure right there.
Okay.
That's just a rectangle.
Okay.
It doesn't have any volume.
Okay.
You couldn't pour water into a you can't pour water onto your rug and expect that your water is going to stay there.
No.
Okay. But if you had sides going up this way, you had a solid object and it was watertight, you could pour water into it. Okay. So I'm drawing a solid object right there. Okay. And I'm going to go like that. I mean, that has meaning to you, doesn't it? That's a solid. That's a dice.
Right.
Okay, solid object. Well, we're not going to worry about perimeter, but the area would be the length, the width, length times width times height.
Okay.
Or in the case of a square, it would just be S times S times S. Because they're all the same number.
Okay.
Or X times X times X, whatever.
Okay.
But if it's a rectangular solid, looking like that, okay, it would be length times width times height.
Okay.
LWH.
Okay.
That would be the volume.
Okay, that's for a cube.
Well, this is no longer a cube. This is a rectangular solid.
Okay, rectangular, but it has to be a solid.
Well, it doesn't have to be solid inside, but it has to have. It doesn't mean that it doesn't matter whether there's air inside or whether there's lead inside. It doesn't matter whether it's filled up with concrete or whether there's just air inside.
Okay.
Still, the area, we call it a solid area.
Okay.
Okay. So, those are the important formulas. And right here, they're talking about cubic feet. Okay? When we have something like this, if we wanted to order concrete to fill this up, we would talk about how many cubic feet of concrete we'd have.
Okay.
Okay.
So that would be the center?
Well, it has nothing to do with center.
Okay.
It just has to do with how much you're going to put in.
Okay.
What am I talking about? Is that me? No, it's not me. Is that you?
Well, I think that was yourself. Your phone was the one that
All right.
beeped.
Oh, a message. I don't know who's sending me messages today. Oh, it's just telling me what my phone bill is for this month. I don't need to know that.
That's crazy.
I don't care anything about it. All right. In this case, they're talking about, when they talk about cubic feet, they want to talk, that they mean how many, that when we have a box here and we say how many cubic feet are in the box, we mean how many cubes that are 1 foot by 1 foot by 1 foot.
Okay.
Could we put inside? You see? A cube looks like a dice. Okay. But theoretically, you could make a dice that was so big that it was 1 foot this way, 1 foot that way, and 1 foot that way. It would be a big dice. You couldn't play with it very well, but you could still build a model of a set of dice that had sides of 1 foot rather than a half an inch.
Okay.
Agreed? I mean, you could do that if you wanted to.
Okay.
If you wanted to make play blocks for kids that they could sit on. You could make blocks. You could make play dice that were 1 foot by 1 foot by 1 foot.
That took a long time.
Well, it might, but I'm saying kids' toys sometimes. If you go to a kid's nursery school, they might have toys like that. Okay. So they're saying, when they say how many cubic feet are in this box, they're saying how many of these big 1 foot by 1 foot by 1 foot things can we put inside this box?
Okay.
That's what they're asking you. That's called a cubic foot. When it's 1 foot by 1 foot by 1 foot, that's a cubic foot. If it's just 1 inch by 1 inch by 1 inch, that maybe a dice would be like that. Even that would be a pretty big dice. But that would be a cubic inch. Okay? If it was a yard, this way, length, width, and height, 1 yard, that would be a cubic yard.
Okay.
If we went out in the desert and somehow had enough material, we could build a cube that was a mile on each side.
Okay.
Couldn't we? Well, we could certainly, in the desert, we could certainly make a square that was a mile each way.
Okay.
Okay? And if we can make a square that's a mile each way, we could theoretically put sides on this square that was a mile high. I don't know if we have strong enough glue to hold it, but conceptually, you could think of what a cubic mile is.
Okay.
Okay? Or a cubic meter, if it was metric or whatever.
Okay.
So that's what's meant when we say cube.
Okay.
You see? So in this case, they're asking, a concrete truck is loaded with 6 1/3 cubic feet of concrete. So it means 6 concrete blocks. That's a foot on each side. Is going to fit into this truck. Of course, probably the concrete's not solid at this point. It's just like soft.
Okay.
But it's still that's how we measure volume in terms of cubic measure.
Okay.
Okay. We measure area in cubes of square measure, and we measure fence in terms of linear measure.
Okay.
Fence is just measured by foot. We don't talk about cubic feet of fence or square feet of fence. But as soon as we're talking about carpet, we talk about square feet of carpet. Okay. And when we're talking about concrete, we're talking about cubic feet of concrete.
Okay.
I need how many cubic feet of concrete to pour into my patio to make me a patio. And that's how you would buy concrete.
Okay.
Okay? So that's what they're asking here.
If you don't mind me asking, do you have a restaurant coming?
Ask the lady, and she'll give you a key and tell you where it is. And if your ride comes in, I'll tell him you'll be right back.
Oh, that's right. I was saying come underneath the thing because...
You can't see him when you're in the bathroom.
No, because I would say this thing right here is 7, what have you, and they say they can't come underneath.
Okay.
That's this one.
Well, we have a lot of work to do. A lot of work to do. Me the teacher. I know, because I made all those mistakes myself.